Hey class, in this video we're going to tackle the topic of solving rational equations. Now this is kind of a new topic, moving away from simple polynomial equations and higher order polynomial equations into something that on the surface looks a lot more complicated. Okay, so hopefully my plan here is to give you guys a set of concrete steps that you can take to approach these rational equations so that you can solve them in a more methodical or systematic way. So let's just learn by doing here and jump right into our first equation. Okay, so here in this first equation, you might notice that we have three rational expressions or three terms in general, if we want to put it that way. What you should be able to do is identify the number of terms that you have here because counting that is going to just give you a good sense of what you're looking at. So for instance, we have 1 over n minus 8. That's going to be our first term. It might be a fraction, so we might need to take care of the numerator and the denominator, paying attention to what's going on there. But we really just want to count this whole thing as one term. Then we have our minus sign, and then we have another term here. This number is just a constant, right? So there's nothing fancy or interesting going on here. We have our equal sign, and then on the right-hand side of our equation, we have 7 over n minus 8, yet another rational expression or a fraction that has a variable in the denominator. Okay, so right away, I'm just going to sort of list the lay of the land here. We have three terms. And our first step is going to be, can we identify what the restricted values of this equation are? Now, in class, we talked about what a restricted value is. And so maybe I'll just reiterate what a restricted value is here. A restricted value, and I'll abbreviate this from here on out as RV, is going to be any variable value, in this case n, that forces the denominator to be equal to 0. So if we have values of n uh, that cannot be a solution, so x or n in this case cannot be equal to some number or maybe a set of numbers. Okay. And the way we're going to go ahead and inspect whether or not we have restricted values in this equation is to look at each of the terms that have the variable in the denominator. Okay, so right away, I am really just interested in this term here. I'm not so much interested in this constant because it does not have a variable in the denominator. That's why we call this a constant, because this value 1 is not going to change. But then if I move over and look at this third term, I have 7 over n minus 8. So anytime we have a variable, we have the potential for this term to change into something. And we really want to avoid any of those variable values that will force us to divide by 0. Okay, so the way we can go ahead and inspect this is just look at these denominators. And if we have two different denominators, then we could look at them individually. But in this case, you'll notice that n minus 8 is the same among these fractions. So I'm just going to set n minus 8 equal to 0 and then see by solving this equation, can I find my restricted value? So I'll add 8 to both sides. And then I'll write the expression n cannot be equal to 8. So far, we only have one restricted value. Only one restriction. Okay, kind of squeezing it in there. Only one restriction. So that's going to be step one. We want to find our restricted values. And if we can identify them, we know that these cannot be the solution to our equation. Okay, so we're going to hold that off to the side until the very end when we're done solving this equation. We're going to compare our solution set or our probable solution set to this restricted value to see if we have to throw away any of our potential solutions. Okay. Step two is to use the least common denominator to clear any fractions. So if you were looking at this equation at the very beginning and thinking to yourself, well, this kind of looks really complicated. I wish that we didn't have fractions. I'm kind of intimidated by fractions. Then you're in good company. Most students kind of despise working with fractions. And so we want to use this technique of using the least common denominator to clear any fractions so that we have a problem that no longer has fractions. Okay? How are we going to do that? Well, I like to think of this as we are building the LCD, okay? And the way we're going to do that is I'm going to write LCD is going to be equal to, and the nice thing about finding what the LCD is that you could think about it is if I want to cancel out this denominator, n minus 8, and a fraction is just a division problem, right? This is literally 1 divided by n minus 8. Then if we want to cancel out this denominator, then we have to cancel out division, okay? Which means we're going to use multiplication, the inverse of division, to cancel out the n minus 8. And if we're dividing by n minus 8, then we can multiply by n minus 8 to sort of cancel out this denominator, so to speak, okay? Well, that's going to be really nice here. If we can multiply n minus 8 by this first term, I will cancel out the denominator since it's a common factor, and then I can move on from there. But like with all other equations that we've encountered throughout the semester, what we want to do is multiply that n minus 8 by every single term. We cannot only multiply it by one term, we have to multiply it by every term in the equation. And so what I'm going to do is set up this equation. I'm going to rewrite it, but I'm going to give myself a little bit of space to multiply the LCD, which is this n minus 8, by every single term, okay? So by this first term, I'm going to multiply it by n minus 8. And you can put it sort of on top of the fraction if you prefer. Some students like to put this over 1 so that you have a fraction times a fraction, but I don't think that it really matters here. That's the first term that we're multiplying by the LCD. Minus 1, but we need to multiply this term by the LCD also, n minus 8. Okay, so that LCD happens to be a binomial, but we have to multiply it by every single term. Finally, we're going to have 7 over n minus 8, this third term, and we're going to multiply that by n minus 8. And again, here, because we have a fraction, you could put this sort of towards the top of the fraction. And if you feel comfortable, you could put it over 1, but I'm going to sort of omit that part here because I don't think it's going to be really necessary. So what we're doing is setting up this least common denominator because you're going to see here in a second that this factor, n minus 8, is going to cancel out the denominator as long as the denominator is a common factor. So if it's the same thing in the denominator that we have in our LCD, they'll cancel out. So if I have n minus 8 divided by n minus 8, we can say those cancel out. So our first term is just going to be left with a 1 left over since that's all we had at the top of this fraction. Minus, now you'll notice in the second term, which was just a minus 1, we didn't have a denominator. There is not an n minus 8 here that's going to get canceled out with our LCD. So in that case, we're just going to simplify by distributing. So we'll take this negative 1 times n, so we'll have negative 1n, or you could just put negative n, that would be perfectly fine. Negative 1 times negative 8 will become a positive 8. Okay? So now we'll move on to our next term. We have equals, and then we have 7 over n minus 8 times n minus 8. Okay? And since this denominator is technically being divided, and we have a common factor here in the top that we're multiplying, that division and that multiplication will cancel out, and we'll be left with 7. Okay. So once you find or build the LCD, multiply that through every single term, what you should have left over is a nice equation that no longer has fractions. We no longer have rational expressions. So here, we're going to solve the remaining equation, but you just need to watch out because that equation may be a linear equation or it might be a quadratic equation, okay? But getting rid of the fractions is the nice thing here. So I'm just going to put as a commentary, we cleared the fractions, okay? Now, all we need to do is simplify and get the n by itself. So if I have like terms, I'll go ahead and combine those. So I have 1 and 8. That's going to give me 9 minus n. So I'm switching this from minus 1n to just n. Just don't freak out that that's happened. Equals 7. Okay. So now I just want to get my variable by itself. I'll subtract the 9 over to the other side. The 9's cancel out. I have negative n is equal to 7 minus 9 is negative 2. And I want to get n by itself completely. So if I have a negative n, I can divide this by negative 1 so that the negatives will cancel out and I'll be left with positive n is equal to positive 2. Okay. So if you can get this far, then you're looking pretty good. We just need to remember to regard this solution as our potential solution. Okay. And the way we're going to check this solution to see if it's correct, this you can think of as step 4, is we can ask ourselves, is our solution a restricted value? Okay. So if we look at our restricted value that we found in our very first step, we said that n, our solution, cannot be equal to 8. Well, is 2 equal to 8? No, right? This is a different number. It is not restricted. And since that's not restricted, then we can say our solution set contains the number 2. And then we can move on with our lives or move on to the next problem. Okay. So there are some ideas here that are a little bit novel to us. In class, we've talked about restricted values. We talked a little bit about finding and building the LCD. But in the next couple of examples, we're going to see some problems that require us to build a little bit more into this idea of the least common denominator. So if you need to pause here and sort of review this first example, the easiest example, please do so. Otherwise, we're moving right along to our second example. Okay. Okay. So in this equation, we have 1 over m squared minus m plus 1 over m is equal to 5 over m squared minus m. Okay, so like I said on the previous problem, it's always a good idea to count the number of terms. And the only reason we're doing that is to make sure that when we find the LCD in one of the next steps, that we have correctly multiplied that LCD the correct number of times into the equation. So if we have 1, 2, 3 terms, I'm going to multiply the LCD, whatever it happens to be, by every single term. So you're going to see this written at 3 different places in this equation. Okay. But for now, we're going to go in the order of the steps that we were given before. So step 1 is to find the restricted values, right? And by looking at the denominators of any of these expressions, we can find our restricted values. For instance, if I set m squared minus m equal to 0, and then solve this equation, then I can find my restricted values, okay? But this is a quadratic equation. So you have to ask yourself, how do I solve this quadratic? So watch out. This quadratic denominator is going to give me 2 restricted values. So I'll go ahead and say, well, most of the time when we have a quadratic, we want to go ahead and factor the denominator. That can be helpful. So we'll factor out an m here, and we'll have m minus 1 is equal to 0. Then applying the zero product property, we'll have m is equal to 0 and m minus 1 is equal to 0. So adding 1 over to the other side gives us m is equal to positive 1. So m cannot be equal to 0. That's one restricted value. And m cannot be equal to 1. So our restricted values include 0 and 1. Okay. But that was just looking at our first denominator. Okay. We need to look at all the denominators, and we'll notice maybe that this first denominator is the exact same as our last denominator. So we don't have to set both of these equal to 0 because they're the same. Okay. But we do want to look at this middle denominator, which is just an m. And if we set that equal to 0, well, we might notice that that's already solved. In fact, m was one of the factors that we had when we set this first denominator, m squared minus m, set it equal to 0. So the reality is we already have this restricted value included here. So we don't need to repeat ourselves. We don't need any duplicate restricted values. We just need the set of our restricted values, no duplications. Okay. So that's going to take care of step 1. The next thing we need to do is use the LCD to cancel out any of the denominators that we have to clear our fractions. So we're going to use the LCD, least common denominator, to clear all fractions. And so here we go. This is the hard part, I think, of these equations is identifying what the LCD is. Okay. And so maybe the easiest way to identify the LCD is if we kind of look at each of these terms. I have 1 over m squared minus m. Well, in factored form, I'm going to put that as m times m minus 1. We factored it earlier to find the the restricted values, but it's going to be really easy to see what do we need to multiply by this first term to cancel out the denominators, or those factors that are in the denominator rather, right? So in order to cancel out an m, we need to multiply this by a factor of m. And then in order to cancel out this m minus 1, we need to multiply this term by an m minus 1. So if we need to multiply by an m and an m minus 1, then that's exactly what we're going to do. Okay, if that's what we need to do, that's what we're going to do. Okay. So you'll see me write m times m minus 1 right here. And maybe let me change color because you can hardly see that 1 right here. M times m minus 1. That's going to get multiplied by this first fraction so that we can cancel out each of the factors in the denominator. Then we're going to do it again. Take m times m minus 1, which was the LCD, and we're going to multiply that by 1 over m, which is the second term. Okay. Then finally we have 5 over, and this was m squared minus m, but we're going to write that in factored form, m times m minus 1. And we're going to multiply this term by the LCD. So I'm going to multiply by m times m minus 1, and I'm sort of spilling over into my scratch work area, which seldom we like to do because it gets a little bit confusing. Now we're going to go through this term by term to start canceling some stuff out. So when I say multiply, I mean that we're implying the multiplication by writing these factors next to every term. We're not actually going to distribute anything out. We're just setting this up so that we can see with our own eyes what is going to get canceled because we want to clear all fractions. And this is going to be really easy to see now. So if we look at our first term, the m factor is going to get canceled out, but also the m minus 1 factor is going to get canceled out. So you can ask yourself, what are we left with? Well, we're left with 1. So I'm just going to bring the 1 down. Then we have a plus. And next, we have our LCD, m times m minus 1. And we're multiplying it by this rational expression that just has an m in the denominator. So only the m is going to get canceled out here. What we're left with is 1 times this stuff in parentheses. So to simplify that, we'll just go ahead and distribute that out. 1 times m is going to be m, and 1 times -1 is going to stay -1. And then we can move over to the other side of the equal sign. And this one's really nice too, because the LCD, both of these factors, are going to cancel out each of the factors in the denominator so that we're just left with the 5. Okay. So once we do that, we're either going to have a linear or a quadratic equation, and we just need to solve the equation. In other words, get the variable term by itself. So if we just simplify this by combining like terms, I know I can combine a +1 and a -1. Those happen to be inverses of each other, so they're going to cancel out. And we'll just have m is equal to 5. And since we have m by itself, that's all we needed to do. Okay, so m equals 5, remember, is going to be our proposed or our potential solution. And in order to ensure that that is the correct answer, we need to check that. So our fourth step is check your solution or your probable solution against the set of your restricted values. So as long as 5 is not restricted, we should be good to go. And we saw earlier that our restricted values are 0 and 1. So that means that our solution set here is just the number 5. Kind of a lot of work going on there. Again, the hard part is going to be correctly identifying the LCD. And it may look like a lot of writing at first, but we're really trying to set us up so that we can cancel out fractions and get something that looks a lot more manageable, a more familiar kind of an equation. And if we can get it to that point correctly without any mistakes, then the rest of the equation should be familiar because it should be back to test 2 or even test 1 material. Okay. So if you need to take a couple of extra seconds to kind of digest this or rewind the tape and go back and start this one over, please do so. But we're going to go ahead and move on to the next and final example here. Okay. So as we did with the previous examples, we want to go ahead and count the terms. Count the number of terms. And in this example, I'm going to go through fewer of these like commentator or like annotation steps over here. I'm going to write out fewer of the steps because I think we kind of have the process down by looking at those previous 2 examples. But we need to understand that you have 1, 2, 3 terms, and they're separated by the equal sign or the minus sign. Okay. So the first thing that we need to do is find our restricted values. And one thing that's going to really help is to factor any of your denominators, because if you have, for instance, a quadratic denominator, chances are that when you're working on one of these problems, one of the linear factors or one of the linear denominators is going to be a factor of that quadratic one. Okay. So we kind of want to, if we notice this, we can reduce the amount of work that's going to be required of us. Because if I take my p squared plus p and I factor it, I know that these both have a p in common. And if I factor out that p, I will have a p plus 1, which happens to be this denominator over here. Okay. And it happens to be the exact same denominator as this middle one. So in reality, we only have to set each of these factors equal to 0 using the ZPP, the zero product property, to find the restricted value. So what we're going to do is say P is equal to 0. That's going to be our first restricted value, comes from this first factor. And then P plus 1 equals 0 reveals that we have a restricted value of P is equal to -1. So I'm going to put a little slash through these. Those are going to be my 2 restricted values. And then the next step is going to be to identify or use the LCD to clear any denominators that we have. Okay. So when I rewrite my problem, I'm going to put p plus 5, and I'm going to write this denominator here in factored form. So this will be p times p plus 1. Okay. Equals, and sometimes I like to leave a little bit of a gap here in front so I can write my LCD. I'll leave a gap here in front to write my LCD, and then I'll write 1 over, and then I'll write this guy in factored form also. So that's going to be p times p plus 1. And then we have a minus, and then this is just p minus 6 over p plus 1. And I didn't give myself a whole lot of space here, but I'm going to put a little gap here to indicate where I'm going to multiply my LCD. So we're going to use the LCD to clear any fractions. And my LCD, if we look at this first term, we're trying to cancel out a p, and we're trying to cancel out a p plus 1. On the next fraction, we're trying to cancel out a p, and we're trying to cancel out a p plus 1. So that means that in my LCD, I must have a p and I must have a p plus 1 so that we can cancel out both of these denominator factors. And that will work for this first term and for the second term. Now, the third term just has a denominator factor of p plus 1, but that's already included in our LCD. So we don't have to write that a second time, because that's just going to complicate the problem a lot more than we need to. We'll see that this is going to be a sufficient LCD because it will cancel out everything we need here in a second. So let's just go ahead and run through that process. I'm going to take my LCD and write it next to each of these terms. So p times p plus 1. And anywhere I have a p, I'm going to cancel out that p. And anywhere I have a p plus 1, I'm going to cancel out that p plus 1. So what I'm left with for this particular term is just p plus 5 equals. Okay. Then in this space that I set myself up with, I'm going to put p times p plus 1 and cancel out any common factors in the denominator. So I'll cancel out the p and the p plus 1, and that's going to leave me with 1. Okay. Then we have minus, and we have p minus 6 over p plus 1. We need to multiply that by the LCD, so that's going to be a p times p plus 1. And only the p plus 1 is going to get canceled here. So just to make this a little bit easier or nicer to look at, I'm going to put this p first, and that came from the LCD. And then in parentheses, I'm going to put p minus 6 here, which is the original numerator that we had on top of that fraction. Okay. So not everything got canceled on that third term, but that's perfectly fine. What we were trying to do was clear all the fractions, and the fractions have indeed been cleared. Okay. So from this point onward, we're just trying to simplify and solve an equation. So we want to solve this equation. And if you have anything, any like terms that you can combine, we want to combine those. But we notice that we need to distribute this negative p and multiply it by the stuff in parentheses here, so that we now have p plus 5 is equal to 1. Then we have a minus p squared, and then we have a positive, because negative times negative is positive, 6p. And now that I have a p squared in my equation, I know that this is a quadratic equation. Okay, so I need to get this into standard form, see if I can factor it using the AC method. If that doesn't work, I'm thinking quadratic formula. So let's see how things go. I want to get this p squared term to be a positive, so I'm going to add that p squared over to the other side. So I'll have a p squared here. I also am going to subtract this 1, and I'm going to subtract the 6p. So the 6p is going to be subtracted here, and the minus 1 is going to go there. I know it looks a little bit messy right now, but these guys will cancel out. So I'm going to have 0 on the right-hand side of my equation. And then over here, I'm going to have p squared P minus 6p is going to be like 1 minus 6, which is going to be negative 5p. 5 minus 1 is going to be positive 4. Okay? So that's a nice trinomial. We can jump right into the AC method here because we're just looking at the factors of 1 times 4, which is 4. 1 times 4, 2 times 2, and 1 and 4 are going to work here, I think. As long as both of these guys are negative, then they will both add to make negative 5, and they will multiply to make the positive 4, so that's going to work out. So we'll go here and split the middle term. Now we should have p squared minus p, because we have a minus 1p, and then we have a minus 4p plus 4 equals 0. We can go ahead and continue with factoring by grouping. So these guys have a p in common. Then we have a p minus 1. These guys have a negative 4 in common. That'll give me a p minus 1 also. So my factors are p minus 1 and p minus 4. And now I can apply the zero product property to solve this quadratic. And I'll have p minus 1 equals 0 and p minus 4 equals 0. So we'll add 1 here. P is equal to positive 1. And we'll add 4 here. P is equal to positive 4. Okay? So the only thing we have left to do is to check this. Fourth step is to check your solution. And we're checking them against the restricted value. So this is a little bit easier than checking our radical equations or our solutions for our radical equations, because we don't necessarily have to plug these back into the original equation. All we're checking to see is, are these restricted? And since my restricted values were just 0 and negative 1, that means that these are not restrictions. So that means we're good to go. Our solution set for this problem is 1 and 4, and then we can move on to the next question or move on with our lives. Okay? So I'll leave that on the screen for just a moment in case you need to pause and like look over the work here. If you need to rewind and rewatch this particular example, you can do so. But you're going to notice that when you're solving these problems, it's going to be a collaboration of a lot of the topics that we've been covering up to this point. We've been talking about restricted values. We've been talking about the rational functions and rational expressions as made up of polynomials. So we should be able to sort of break apart the denominator and sometimes the numerator to sort of use those pieces of information separately to get to where we're trying to go. For instance, when you're solving those equations, you might ask, how do I get the LCD? And the key there is going to be, can you factor the polynomials in the denominator? Because if you can look at all of those factors for all of the denominators, whichever unique factors you get, those are going to help you build the LCD. And once you have built the LCD, you're going to go ahead and cancel those factors out of every term, at least in their denominator where possible, and that will help you clear the fractions. Once you clear the fractions, which is like 80% of the hard work in these problems, the rest of the problem should flow downhill because it's just old material. You're just solving a linear equation or a quadratic equation, okay? So make sure that you review this video, review these problems and some of the problems in the homework, ask lots of questions, and go to MathWorld if you need additional support, because this can be pretty tricky, but the only way you're going to get better is with more practice. So do what you got to do, and if you have any questions, just shoot me a message in Canvas. I will see you guys in the next video. We're going to be talking about graphing rational functions.